Okay, we have just a few more examples left. So our next one is a secant, which we've done one of these already. And for that, we do the whole thing, which is going to be x plus 7 times the outside. So x plus 7 times 7 will equal, and we do the whole here, which is 15 plus 6, which is 21. Times just the outside, 6. So we're going to go through and do a little distribution. We've got 7x plus 49. 21 times 6 gives you 126. We balance our equation, get x by itself. 7x equals 77. So x has to equal 11 units. Okay, so don't forget your units and make sure you are following your patterns correctly. And then we have a secant tangent. So the secant tangent, the tangent's all by itself and it's going to get squared. I'm going to go ahead and write that down, 15 squared. And then we set that equal to the whole of our secant, which is x plus 9, times just the outside, 9. So we distribute, we get 9x plus 81 equals 15 squared, which is 225. You get 9x equals 144. Divide your x, and you get x is equal to 16 units. So some of these go pretty quickly. I would keep, your setups, your formulas handy so that you can reference them until you get comfortable with remembering which ones happen with which situations and what fully occurs. Now we're going to go through one more problem. This is kind of a little bit of a challenge problem. So an archaeologist finds a portion of a circular wheel with the dimensions shown in the figure. What was the diameter of the complete wheel? So I'm looking for the diameter. In order to have the diameter, I'm definitely going to need to find the radius. So I am going to look at this piece that's provided for me. I can see I have a chord of 9 and 9, so it's split, it's congruent. And I've got some magical piece that's going to give me the radius. But I know that radius is also going to go to the other end of that chord because magic of radii. So this is a radius, but this is also, not that. This is also a radius. And so I know the entire radius is r. I'm going to move that over here, r. But the portion that we're using, get a color that's going to stand out, from the radius to this crossing point, I'm going to denote as r minus 3. So if you need to hop that triangle out to look at it a little easier, you're more than welcome to. I've got my right triangle. I have a side length that says r minus 3. I have the radius, and then I know one side was 9 inches. So now I need to do Pythagorean theorem to solve for my radius. So we do 9 squared plus r minus 3 squared equals r squared. 91, or 9 squared is 81, plus, now remember, this is a big deal. Please remember about this. R minus 3 squared turns into r minus 3 times r minus 3, and you have to FOIL. Please, please, please do not forget that. Please, please, please do not forget that. You need a FOIL there. So when you FOIL that, you get r squared minus 6r plus 9 equals r squared. So now I'm going to go through and try to get r by itself. That leaves me with 81 plus 9, 90 equals 6r. So r is going to be equal to 15. And of course, I'm looking for the diameter, and I'm given the radius. So if I'm going from diameter to radius, I need to multiply by 2. So I'm going to get 30.